Hello everyone, my name is Nikhil Kant and this is my presentation for Physics 2112 Lab 30. So for the introduction, in this lab, the purpose of it is to measure the distance dependence of the magnetic field due to a small bar magnet and compare my measurements to the distance dependence predicted by the equations for the on and off axis magnetic field derived from the Biot-Savart law. And for a quick glance at what I got, the n I got is negative 3.05, and the natural log of k is negative 14.651. And here's some of the fundamental physics principles and formulas used. And here's the Biot-Savart law, and here's the distance dependence formula used. And so for my assumptions, I assume to treat the bar magnet as a magnetic dipole that functions as you can see in the image on the right. So for the experiment, the initial conditions were I have a magnetometer on my phone, which I downloaded, and a bar magnet. And for the system is a bar magnet, and the surroundings is everything else. Now for the experiment, the procedure was first I had to compensate for the Earth's magnetic field, and if I didn't do this, then all of my results would have been skewed. And after I did that, then I marked the phone with a piece of tape where the absolute value of x is at its minimum and the absolute value of y is at its minimum. And you can see that in the second image. And then, after that, I rotated the phone 90 degrees and I did the same for the absolute value of y. But this time, the absolute value of y had to be at its maximum and the absolute value of x had to be at its minimum. And this is the data I got. So for each distance, R20, R70, R120, R170, and R220, I plugged in the values I got in the yellow, and the output is in the blue, which Excel calculated for me from the data. And this is the data analysis. And as you saw in the introduction, the value of n I got is negative 3.0525, and the natural log of k is negative 14.651. And as you can see in the graph, the two lines are very close to being similar, almost exactly the same. And this is good, which means our data is fairly accurate. And here is the off-axis data. And as you can see, the procedure was the same for the procedures before. However, this time the phone is off-axis, as you can see in the image. And again, I plugged in the data in the yellow boxes, and then Excel calculated everything for me in the green boxes. And this is the data and results that I got from the off-axis data. So for my sources of error, one source of error could be that the magnetometer may have not been calibrated correctly or accurately. And because of this error would skew the results of the data. Another source of error could be that the phone, when positioning on the axis on the bar magnet, could have been slightly rotated or tilted. This would have caused a great error in the data. And for my what-if questions. What if I hadn't oriented my experiment to compensate for the magnetic north? Well, if I didn't do this, then the results would have been affected by the Earth's magnetic field, which would have skewed the results and made them be inaccurate. Now, what if I were to put two identical magnets together? What would happen? Well, if I were to do this, then the measurements would have doubled, but the direction would have been the same. And these next few slides, I'll show you the code that I used to calculate the image you can see in the last slide. And this code was obtained from the lab instructions, and I added in my own data and changed the code to make sure it worked. And here is the second part of the code. as you can see, and all of this code yields this image you see. And that is it. Thank you for your time.